So derivatives using data. Let's look at this example. Water is flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by the differentiable function W for T that it's in between 0 and 24, where T is measured in hours and W of T is measured in gallons. Values of W of T at selected values of the time T are shown in the table below. Okay, so you have T hours and then the gallons. Okay, so let's look at the questions over here. Use the data in the table to find W of 8. And you're like, oh, this is not even a calculus question. No, it's just looking at the tables, right? So don't overthink this. What's W of 8? W of 8 is 221 gallons. Okay? Okay, so that one was easy. It wasn't even calculus. Use the data in the table to find the inverse, okay? W inverse of 257. This one is not calculus again. We're in pre-calc or somewhere there. Okay, so you're like, okay, so I'm going to look for the output 257, which is here. So what's the input in this equation? So you know that the function inverse to W evaluated at 257, it gives you what? 12, okay? 12 hours, okay? Okay, so those were pre-calc algebra 2 questions. I'm not sure which of the two. Okay, so for the last one that we have over here, well, it's not the last one. Use the data in the table to find the approximation of W prime of 15. Show the computations that lead to your answer using the appropriate units. Explain the meaning of your answer. Okay, so what do you need to find? Actually, you need to find the average rate of change, right? On what interval? The interval what? Well, let's see what interval. Okay, so they are asking you for 15. Okay, so let's look. Where's 15? I don't see it, right? So what's the interval that you're going to compute? The closest to 15. Okay, that's in between, so it's going to be on the interval 12, 16. Okay, so what's going to be the average rate of change? The average rate of change is going to be equal to W of 16 minus W of 12 divided by 16 minus 12, and this is going to be equal to 294 minus 257 divided by 4, which is 37 divided by 4 gallons per hour. Okay, and that's going to be your average rate of change. Okay, now let's look at D. Okay, use the data in the table to find the average rate of change of W of T over the time period 4 and 20 hours. Show the computations that lead to your answer, and they give you a huge hint here. Okay, well, this is not a hint. We already used it before, so it's not a very good hint. Okay, so what are you going to do? Average rate of change of W of 2 minus W of 4, okay, divided by 20 minus 4, which is going to be equal to, look at your table, 327 minus 184 divided by 16, and then you have that this is equal to 143 divided by 16, and you know that this is gallons per hour. So you can see that application problems actually are pretty easy. Okay, so the last one that we have over here, let me just show you here. For T that it's between 0 and 24, please note that this is not including them. Must there be a time T when the tank contains 265 gallons of water? Justify your answer. This one looks really interesting. Okay, so 265. Okay, so you realize that it happens from here to here, right? But we don't know exactly. Okay, so what this is smelling like, you know that W is differentiable. Okay, so since W is differentiable, what do you know that it's happening to the function? We know that W, the function W, is what? Continuous, and this smells like what? IVT. Okay, and moreover, second condition, you know that W of 0 is equal to 150, and W of, what was it, 24 is equal to 357, being different, second condition met. And the third condition, what do you have for the third condition? The third condition, you know that 265 is in between 150 and 357, so you have that third condition is met of the IVT. Okay, after that, okay, the IVT, okay, guarantees the existence of a time, okay, in the interval 0-24, okay, so that W of t is equal to 265. Can you find it? No, we don't have the function, but you know that it exists, and that's why the IVT is so important. So for this one, we have that a model for the amount of water in the tank is given by A of t is equal to 1/225 times negative t cubed plus 30 t squared plus 1800 times t plus 33,750, where A of t is measured in gallons and t is measured in hours. We need to use the calculator to find this. Okay, so if you have a CAS or a CX calculator, this is what I'm going to do. Okay, so so we turn my calculator. Okay, so I have this. So what you're going to do is you go to menu, calculus, and then you go at the derivative at the point. Why the derivative? You have the prime and you have the point. What's going to be your point? 15. Okay, so the value you want, value 15. Okay, so you go to OK. After that, what are you going to do? Surprise, surprise, you're going to plug all that situation in your calculator. So you have that it's 1 divided by 225. Okay, and then I would do parentheses there, okay, to be more specific. So and I always use x's instead of whatever variable they give me to keep it consistent with myself. Okay, so you have plus 30 times x squared, then we have plus 108, and I'm doing slowly so you can see what's going on, plus 33,750. Okay, I work with that, so plug it in. You plug it in, and that gives you 9. Okay, so what are you going to do? You know that A prime of 15 is equal to 9, okay, gallons per hour. Now you know how to plug it in the calculator. Okay, I'm showing you so you know how to use the calculator early enough. Okay, so use your calculator again and the model given in part F, okay, so this one, to find the average rate of A of t over the time period 4, 20, including the 4 and 20. So you know that A of 4 is going to be what? We plug it in the calculator, okay, and when we plug it in the calculator, I have that it's 183.849. okay, I just plug it in this one, okay, and then A of 20, I have that it's going to be equal to 327.778. okay. After that, what are you going to do? You know that the average rate of change of the situation is going to be equal to 820 minus 84, okay, divided by 20 minus 4. Okay, so you know that this is going to be equal to 327.778 minus 183.849, and all of this is going to be divided by 16. You know that this is going to be 143.929 divided by 16, and what you have is that 8.99556 gallons per hour is going to be the average rate of change. How many decimal places do you need to put? 3. I would stop here. Okay, you can round up and down, but I would always use 3 decimal places.